If you travel 120 kilometers in half an hour, how fast are you going? These are the types of questions we're going to be answering today using our speed, distance, time formulas. So there's three formulas we need to know. The first one is as follows. Distance equals speed times time. Time equals distance over speed is the second. And speed equals distance over time is the third. Now, it might be tricky to remember all of these three, so this is where we can use some formula triangles to help us. And you might have seen these formula triangles used in things such as SOHCAHTOA or mass force acceleration. But you basically cover up the one that you are looking for. So if I was after distance, I would cover that up, and it tells me to do speed times time. If I was after time, I cover that up, that's why it's highlighted, and it tells me to do distance over speed. And finally, if I cover up speed, it helps me decipher that I need to do distance divided by time. So use that formula triangle to help you, because there are three different formulas which you would need to rearrange without the formula triangle. So let's apply using that formula triangle. So here's our formula triangles. The first one, it says, what is the speed of a car which travels 100 kilometers in 2 hours? So we're trying to find the speed. So we would go down to speed, cover it up, and it would tell us to do distance divided by time. The distance is 100, the time is hours, so our answer is 5, but the units are kilometers per hour, okay? So we combine the two units from distance and time there to come up with kilometers per hour. The second one says the pigeon flies for 5 hours at a speed of 70 kilometers per hour. Calculate how far the pigeon flies. So we're after a distance this time. So we would cover up distance. That tells us to do speed times time. So we're going to do 5 times 70 to get 350. And we're after a distance this time. So that's in kilometers. And then the last one, it says a lorry travels 80 kilometers at an average speed of 20 kilometers per hour. Work out how long the journey lasts. So we would cover up time, telling us to do distance divided by speed. 80 divided by 20 is 4, and that is 4 hours. So now let's apply this to graphs as well, because that is another common type of question where we have speed, distance, time graphs. So you can see from this graph here that time is represented on our x-axis and distance is represented on our y-axis. And what happens is, if the line is flat, that means that we are stationary. If it is traveling in a constant gradient, that is a constant speed. And gradient also tells us how fast we are going. So we'll mention more of that in a moment. And then we can see here we started traveling away from our original point, stayed and had a rest. Maybe we were at a petrol station or something, and then we returned to the start. Okay. So we can use that to help us calculate speed as well, because if we have a look here, the object travels 5 meters in 2.5 seconds. So if we draw a right angle triangle, we can see that every 2.5 seconds, we cover a distance of 5, okay? This one, they've decided that the distance is measured in meters and the time is measured in seconds, but that is something we should put on our axes as well. So just be aware of that. If we don't have any units, we are kind of assuming, so just check that units are on your graph. But drawing a right angle triangle can help you find the speed. And you could draw any right angle triangle on this line here. That would still give you the same answer of 2 meters per second when you did the change in distance, how far up, divided by the change in time, how far across. And in general, the steeper the line, the higher the speed. So if I've got two lines, or I'm looking at my entire graph and the question asks me, at what point am I traveling the fastest? I need to look for the line which is the steepest, okay? Because the steeper the line, the higher the speed. Here, there's like no speed at all. I'm just stationary. But if I have a very steep line, that means I'm going very quickly. I hope this helped you see the relationship between the formula triangles and then how we use that knowledge to draw speed, distance, time graphs as well. If this is helpful for you, then please subscribe to the channel. I appreciate it. All the best.